Light travels at 300,000 kilometers every single second. Fast enough to circle the Earth 7 times before you finish reading this sentence. And yet, if you fired a beam of light right now toward the edge of the observable universe, it wouldn't arrive in your lifetime. It wouldn't arrive in 1,000 lifetimes. In fact, it would never arrive, because the universe is expanding faster than light can cross it. By the end of this video, you're going to understand just how small you, me, Earth, and even our entire galaxy really are, and it might change how you see everything. Let's build this up in stages, because jumping straight to the universe is meaningless without context. Start with Earth, about 12,742 kilometers across. You could drive around its equator in a few weeks, not exactly small to you, but let's zoom out. The Sun is next. You could fit about 3 million Earths inside the Sun. And the Sun isn't even a big star, it's just average. Now the distance from Earth to the Sun, about 150 million kilometers. Light takes roughly 8 minutes to cross that gap. So when you look at the Sun, you're seeing it as it looked 8 minutes ago. That's step 1. And we've barely left home. Keep going outward. Neptune, the last major planet, sits about 5 billion kilometers from the Sun. Light takes about 4 hours to reach it. Beyond Neptune is the Kuiper Belt, a vast ring of icy bodies including Pluto. And beyond that is something almost nobody pictures correctly, the Oort cloud, a theoretical shell of icy debris surrounding our entire solar system, extending possibly a full light year out in every direction. To put that in perspective, Voyager 1, the fastest, farthest human-made object ever launched, left Earth in 1977. It's been traveling for nearly 50 years. It still hasn't left the Oort cloud region. At its current speed, it would take roughly 30,000 years just to cross it, and that's still just our solar system. The closest star system to our own is Alpha Centauri, about 3 light years away. That means light, the fastest thing in existence, takes 3 years to make that trip. If Voyager 1 were headed there directly, it isn't. It would take about 73,000 years to arrive. So even the nearest star system is, for all practical purposes, unreachable with current technology. And that's the star right next door. Now zoom out much further. Our Sun is just one of an estimated 100 to 400 billion stars in the Milky Way galaxy. The Milky Way itself is roughly 100,000 light years across. Light, again, the fastest thing that exists, takes 100,000 years to cross from one side to the other. Our entire solar system, the Sun, Earth, Voyager, everything we've ever built or sent anywhere, sits in a fairly unremarkable spot about 2/3 of the way out from the galaxy's center, in a region sometimes nicknamed the Orion Arm. We orbit the galactic center once every roughly 230 million years. The last time our solar system completed one full lap, dinosaurs hadn't gone extinct yet. The Milky Way is not special. It's one galaxy among an estimated 2 trillion galaxies in the observable universe. Not stars, galaxies. Each one potentially containing hundreds of billions of stars of its own. The nearest large galaxy to us, Andromeda, is about 5 million light years away. It's actually on a collision course with the Milky Way, though the merge won't happen for about 4 billion years, so no need to panic. Beyond Andromeda are galaxy clusters, then superclusters. The Milky Way itself belongs to a structure called the Laniakea supercluster, a web of galaxies stretched across roughly 500 million light years. At this scale, entire galaxies start behaving less like objects and more like grains of sand, scattered across an unimaginably large beach. Now for the number that breaks most people's intuition. The observable universe, meaning the portion of the universe whose light has had time to reach us since the Big Bang, is estimated to be about 93 billion light years across. Here's the part that trips people up. The universe is about 8 billion years old. So shouldn't the observable universe only be 8 billion light years across, since light hasn't had more time to travel than that? The answer is space itself has been stretching the entire time light has been traveling toward us. It's called the expansion of the universe. So the ancient light we're seeing left its source when that object was much closer to us. But by the time the light arrives, the source itself has drifted much farther away due to that stretching. That's how we end up with a 93 billion light-year wide observable bubble from a 8 billion year old universe. And that's just the observable part. the part whose light has reached us. The actual universe, beyond what we can ever see, may be far larger. Some models suggest it could be effectively infinite. We simply have no way to know, because light from beyond our observable horizon will never reach us. The space between is expanding faster than light can cross it. This is the part that really breaks people's brains. There is no edge you could ever fly toward and touch. As you travel outward, new sky keeps appearing ahead of you, precisely because the universe has no observed center and no known boundary. Every point in the universe experiences itself as being at the middle of its own observable bubble. That means somewhere, right now, other observers, if they exist, are looking out at their own 93 billion light-year bubble of sky, seeing stars we will never see, in directions we can never reach. Let's zoom back in, one last time. Earth, one planet among at least a few thousand confirmed exoplanets, among an estimated hundreds of billions in our galaxy alone. Our galaxy, one of an estimated 2 trillion. Our observable universe, quite possibly a small local pocket of something even larger, maybe infinite. And you, reading this sentence right now, are a collection of atoms that were literally forged inside dying stars billions of years before the sun even existed, arranged in just the right way to be able to look up and ask, how big is all of this? That's not a small thing. That might be one of the rarest things in the entire universe. So, how big is the universe? Big enough that big stops meaning anything useful past a certain point. Big enough that the fastest thing in existence still can't cross it in a human lifetime, or 1,000 lifetimes, or maybe ever. And yet here you are, on a small rock, orbiting an average star in an unremarkable arm of one galaxy among trillions, somehow able to comprehend all of it. If this kind of perspective shift content is your thing, subscribe, because I break down the universe like this every week. And I want to know, does thinking about this scale make you feel small and insignificant, or does it make you feel amazed to be part of it? Let me know in the comments.